Hello, and a warm welcome to Prompt Engineering Conference 2024. I am Bethany Jepchumba, and I'll be taking you through inside multimodal models. A little bit about myself before we get started. I am a cloud advocate at Microsoft, and in case you need to reach out to me after the session, you can find me on the internet at Bethany Jep. In this session, we'll be covering a lot around multimodal models, understanding the inner workings of these models, understanding what modality is, and following up with a couple of demos to showcase how you can apply multimodal models in your day-to-day life. We are currently living in the era of AI, and over the last few years, we have seen the speed of innovation in the AI space be truly incredible. The breakthroughs, there are a couple of breakthroughs happening many times a week across the entire industry. And about more than 50% of the organizations have adopted AI in at least one business area. And 70% of employees are ready to test out AI and see what it is about. The idea behind AI and generative AI has been language models can be able to generate new context. And in majority of the times, we've seen the content is particularly of one modality. For example, having content in natural language, interacting with chats, or having models that interact with the modality of vision or speech only. But in reality, models are amazing, but in reality, we as humans interact with the real world using multiple senses. Since computers have been unable to interact across multiple modalities, it has meant that us human beings have had to learn how to interact with computers versus the other way around. But now, everything is changing. The question around multimodality is we as humans can be able to grasp all these different modalities. We can be able to see, interpret different languages, and speak out loud almost at the same time and almost simultaneously. But why can't large language models do the same? The modalities available currently include language, and we have models such as GPTs, which understand and generate natural language. And then we have Whisper, where models such as we have speech, where models such as Whisper are able to understand and generate spoken language. And finally, we have Vision, where models such as DALL-E generate new images from textual prompts. But now, when large language models come into play, models can be able to process multiple data types, for example, text, images, audio, and vision, and reason across various scenarios. Before we go further into the inner workings of multimodal models, the first thing we'll do is define exactly what the technology, the architecture behind it is. And the first one is the attention mechanism, whereby models are able to weigh the importance of different parts of the input data and provide better context understanding. The attention mechanism demands a focus on what is relevant at hand, and you can be able to build relationships within a single modality or cross modalities to be able to now give contextual understanding and provide insights on which text is more valuable than the other based on the question asked. And then the transform architecture, which relies on these attention mechanisms to be able to transform data and ensures you can be able to handle multiple modalities. For example, you can define specific encoders that feed to a shared transformer layer. And these encoders, once in the same layer, can be able to come in and perform multimodal examples. Then, onto the multimodal models. I'll talk about two today. The first one is CLIP, which is contrastive language image pre-training, and DALL-E. How CLIP works is you're able to get a lot of image and caption pairs, encode both of them in different encoders, and have the embeddings in the same vector space, whereby now you're able to match those with a similar pair, and those that are not similar, the pairs that are not matching, are able to be, those pairs that are not matching are able to be minimized, ensuring you're able to now get a better response based on what your input will be. For example, if you want to classify images or generate a new image, it will be simpler to do so because you can be able to have the caption there and get an image decoded for you. And then the next one is DALL-E. How DALL-E works is you're able to give a prompt and get a response based on the prompt you've given. The mechanisms behind it is the training data, whereby we have billions of parameters used to train the model. These are vast parameters that contain image and text pairs, which are now able to give the association between textual and visual information, therefore allowing you to be as creative as possible. And the more the data, the better the performance of the model, up to, of course, a certain level. And at the base of DALL-E is transform architecture, which of course ensures you're able to have the attention mechanism to decode text prompts and transform it into images. We've talked a bit about the theory, so let's see multimodality in action. Before we go into it, the first thing I'll mention is you can be able to access all these models on Azure OpenAI. And some of the models you can access on Azure OpenAI for specific modalities include something like GPT-4 with 3.5 Turbo for your text generation, Whisper for your audio generation, and DALL-E for image generation. But today we'll be exploring GPT-4o for our multimodal examples. So onto the demo. A way you can be able to apply GPT-4o, that is a multimodal model, is, for example, getting detailed descriptions of your image. So I will upload an image of my cookies that I recently baked and ask what is in the image. The response should be a description of what exactly the image is about, and it shows a baking tray with several cookies on it. The cookies appear to be homemade, slightly golden brown color, they're uneven, and it's very characteristics of many homemade cookies. So I can ask, okay, how can I improve my baking based on now the feedback I got from the model? And it will give me ideas of probably should be able to do this and this. Let's give it a second as it loads. It's still generating the response. So let's give it a second, and here's the response. So first, ensure you read the recipe, quality ingredients, the accuracy in measurement, and so much more, which ensures your baking is way better. The next way is you can be able to use your model to be able to detect if there's something wrong with a particular image. So I can be able to upload any of these images. Let's upload this cake that was generated by DALL-E, and I can ask, is there an anomaly in this image? A good use case for this is especially in areas that experience things like droughts or floods. You can be able to upload different images and understand what is happening there. Oh, so this cake does not have any anomalies. It's aesthetically pleasing, and everything is well done. So yay, no anomalies in the cake. And then the other bit you can be able to do is help you understand and generate graphs. So I have a Power BI graph here, and I can be able to ask DALL-E to explain the dashboard, what I can be able to add into the dashboard. When first done, I can be able to upload it, and it will give me a description of this dashboard, which shows a retail analysis of sales, the sales based on the number of stores, the sales that happened that year, where did the most sales comes from, and more details around the sales in the store. So let's give our Azure OpenAI model a few seconds for it to finish replying. Then we can be able to check out the answer. Okay, seems like there's a problem with my... Yep, here comes the reply. So we can be able to see the further sections and what the sections indicate. These are other sections, what it indicates, so the top section, the middle, and then the bottom section. And it's also telling us what additional metrics we can be able to create. So probably I can ask, how can I increment the sales trend over multiple years? And it's able to give me step-by-step instructions to be able to now be able to create this multi-year trend analysis to see the long-term growth and decline of the sales over the period of time. And then once you're done with DALL-E for ensuring you can be able to create and generate your different graphs, create more graphs, you can also be able to convert this into code. For example, if you have one of the graphs that really and you want to convert to code, that's something you can be able to do. The other ways you can be able to use multimodality is translating between different languages. I don't know, but there's sometimes you find a sticker and it's in a very different language, maybe on your clothes or maybe even a poster on the wall. Or you're visiting a new country and you're seeing all these posters and you want to get a translation of them. You can just take the picture of the image and upload to GPT-4o and get a response based on that. And then the last bit of how I use this in a personal level is I use it for my designs and for my drawings to be able to now get feedback of, okay, this is the drawing I made. Can you be able to convert this for me? Or using it on my handwriting to be able to tell, okay, are you able to give me feedback based on this if there's anything I need to change about my handwriting? So those are the different use cases for GPT-4o. And as we wrap up, we've been able to cover what exactly GPT-4o is about, what exactly you can be able to do with the different multimodal models, how you can be able to implement them. So my final parting shot is you can be able to join the Agile community on Discord to learn more about these multimodal models, learn how you can be able to build them, and also get started with the generative AI course for beginners, which gets you into now, yes, we learned the basics, so how can you continue forward and create more robust applications? Thank you so much and have a good day.